Welcome everyone, and this is going to be a presentation and then a demo on running a Jupyter Notebook in your Kubernetes cluster. We're going to go ahead and show you how to deploy a cluster using Platform 9, and then we'll go through how to actually get access to the notebook. But this is 101, so I'll do some introductions. So I'm Mike Petersen. I'm a technical marketing engineer at Platform 9. Work with Kubernetes stuff, write blogs, make videos, and try to create helpful content. With us is Matt Rourke. He's a principal cloud support engineer. He works on the support side and helps customers get stuff fixed every day. We got Janae too. She's not actually on here, but she's part of this and she helped put this all together. Everything I'm going to be doing today is on GitHub. I will share the link after the slides are done in the chat, unless Matt wants to. Everything's there. So if you don't get a chance to walk through this while we're doing it now, and you want to do it later, go ahead and go here, and it's the 101 content. There's YAMLs in there that you can use to deploy the READMEs in there too that kind of walks over everything. And so today what we're going to do is we'll talk about some of the Kubernetes benefits for doing this on Kubernetes. We're going to do a basic deployment of just a Jupyter notebook, but you would want to look at something like Jupyter Hub to manage a bunch of users that will let you deploy a bunch of different notebooks for each person. That'll kind of let you take advantage of being able to use more of your cluster by having a bunch of containers running on each node. Some of these can use a lot of resources too, so it's good to be able to deploy them to other nodes that have resources available. So we're going to deploy a cluster using Platform 9. We're going to configure cluster storage with the CSI Hostpath driver. This is kind of like just showing off how the app catalog works. You're not necessarily going to use Hostpath when you're doing this in production, like you may use something like Rook and Ceph, but this will at least get you familiar with the app catalog. You can actually deploy Rook and Ceph with the app catalog too. It just takes a little bit more configuration on the nodes beforehand. We're going to deploy a Jupyter Notebook. We're going to run Hello World on the Jupyter Notebook when we get it running, and then we're going to download and run a Tensorflow example notebook. So with that, let's go ahead and get started. Let me bring up my Platform 9 UI. So for this, I've got 3 nodes running. I gave about 16 gigs of memory, and they've got 8 CPUs. You can do this with smaller resource amounts. Like I actually did a test deployment with 4 CPUs and 8 gigs of memory. It's just going to take forever. So the more resources you can give it, these are VMs. You can do it bare metal or VMs. Bare metal is probably going to be a little bit faster. But for this demo, I just have 3 32 gig memory virtual machines with 8 CPUs. So let me go ahead and walk through. So I'm going to deploy a cluster with, get this out of the way, Metal LB so that we can use load balancers. But in the examples, I've got an example for load balancers and an example for node port if you don't have access to load balancers, or if you can't set up the networking space to support load balancers to begin with. So you can still do it on node port, and I'll walk through how you can use each of those. All right, so we'll create a cluster. We're going to do a single master cluster. Name it demo. This is just like the wizard walkthrough to create a cluster in Platform 9 if you aren't familiar with it. I'm going to kind of walk through a little bit quickly. So here's our master node. I'm going to add 2 worker nodes. I could probably get away with 1 worker node just to test this out if you don't have enough resources. The nodes are using Ubuntu 2004. Yep, there you go. Matt's sharing that. I'll have some of that information here. So this is actually the GitHub. So each of these things that I'm walking through and talking about is actually here in case you forget or you want to see what some of the requirements and stuff are. So just bare metal or VMs running Ubuntu 2004. We can set up load balancer or node port for it. Like I mentioned before, you could do workers as small as 8 gigabytes of memory and 4 CPUs. But like I said, for this, we're going to run something a little bit bigger, so hopefully it'll run a little bit faster. So I'm going to deploy Metal LB. Maybe I'm talking a little bit quick. I don't know, Matt, just slow me down. I'm going to deploy Metal LB, which this is actually going to give us on-prem or bare metal /VM load balancers, which is one of the big issues with deploying locally. Is every single example that you see out there usually uses a load balancer because it's assuming you're deploying in a public cloud or something like that. So this kind of gives us the opportunity to run those same things within our local environments. Let's see. So I've got it set up to where Yeah, there's a, thanks, Matt. Yeah, there's a blog post too about it if you want to look at our blogs. All right, so I'm going to actually just set up five IP addresses. Really, I'm just going to end up using this one for everything. I've even got like a record in my host file for Jupyter, just so I can copy paste and make things a little bit quick. So if you do have it set up, you can set up a couple of different ranges. This range is within my IP address space that I'm using for everything at my home network. Like I'm actually just deploying this on a DL360 that I've got, 3 VMs running on, and I'm just saying this is where that IP address space lives. All right, and then we can finish and review. That's all the configuration we're going to do. We're not going to do anything else custom. So while we let that deploy, Matt's posted a couple of things about how using MetalB to add the load balancer service. So there's some information about how to do that without using, I think, the UI and everything too. You can deploy it after the fact if you like set up network space after you've already got a cluster running. We kind of make it a little bit easier in the UI by giving you a configuration option. All right, so we've basically just started a deployment of our Kubernetes cluster. Are there any questions around that? Matt linked to the free tier stuff where you can actually go sign up. So if you have some hardware available, or if you have like one server and a couple of VMs running, then you can use this to deploy on it. You just got to set up a free tier account. And basically just walk through the same wizard like I did. I did a little bit more configuration than this beforehand. Like you have to check the nodes in, which means it's downloading a CLI to it and then authenticating it to your DU, we'll call it DU. Authenticating it to your environment, we'll say that. And then once you do that, you'll have a couple of nodes available and you can deploy the cluster with that. I think you could do it like all in one. You probably have a better experience doing around three to five. Normally you can also have it where it'll run the master node is like a worker node too, so you can run stuff on there. But for most of my examples, I'm just using like 3. Like more like you probably want like 4, so you have 3 workers available, so you're not doing stuff on the master in case you want to like scale out. But take a couple of minutes and this will actually finish deploying. And then once that's done, what we'll do is download the kubeconfig and start deploying some stuff. So if I go over here, I can actually start walking through some of this while it's deploying. So what are we going to deploy? We're going to deploy a load balancer service that's going to sit in front of the Jupyter pod that we're deploying. So this is actually the Jupyter pod notebook. If we scroll down, the Jupyter pod notebook is just using Jupyter's own TensorFlow notebook container on Docker Hub. So we're using the basic things that they have. So like we're not doing anything custom. We're not creating a new image. We're just using what they have publicly available. We're telling it what port to expose. And if you look at the load balancer, it's telling it where to map the port 888. So we're going to end up, once I get it running, I'll show you the IP address and the port that comes up. We're creating a volume mount. So after the cluster is running, I'll go ahead and create storage, and we're going to mount that storage so that we have persistent storage. So like say the container dies or we delete it, we can just create a new one and remount that so that we can have our work saved. And then we're running in a init container to actually change the permissions on that so that we can write to it within the notebook. So I'm talking pretty quick, going pretty quick. Do we have any questions or anyone have anything they want to say? Looks like Matt posted some of our blogs and other stuff. I'll try to add, like I'll end up creating a blog post about this too, and then have links to this in case you even missed the GitHub link here. It's like Matt, you did post to everybody, so everybody should have it. We're going a little bit quick, so it'll be it's probably too difficult to walk through this while we're doing it in a workshop. Like for walking through, we'd probably want closer to 2 hours, but we want to save everybody some time, and I'll walk through the demo and then post this as a video later so that you can rewatch the video too if you need to while you're walking through this on your own cluster. And nothing that I've created here in these deployments is specific to Platform 9 or anything like that. So you can just run this if you already have a Kubernetes cluster running. You may want to change a couple things like putting in a different namespace. This is just going to use the default namespace because I'm not running anything else on this demo cluster. Let's go ahead and see if it's finished deploying. Nope, still going, almost done. I'll pause for a moment while we wait for this to finish out, and that'll be start our next step. You got any comments or anything, Matt? I just rushed through the beginning of that pretty quick.
So one thing I'll mention is as we're running through this in terms of getting an environment up and running is if you don't have any available hardware necessarily, there is an OVA image and you can use something like VirtualBox. You still need, at least still probably 8 gigs of RAM or so to dedicate to it. But this is something that you can test using on your local machine. And it's just a proof of concept and for learning purposes. So if that's something which is a barrier of entry in terms of getting started, that's somewhere that I would recommend to take a look at.
All right, you can see this right, Matt. So this is the OVA here. If you wanted to onboard a node instead of using the CLI. So what I did basically is I used the CLI to onboard the node. But if you wanted to use a VM template, like Matt's saying, you can just go here within the node section and then download the OVA, and you can do like an all-in-one. It might use a bunch of resources on your machine, and if your laptop's not pretty substantial, it might slow things down a little bit, but it'll at least run, and you can start testing it out.
Otherwise, so like Mike mentioned, you can run this on any cluster. We do also have an option to import your cluster. It does come with slightly more limited functionality than if you deploy a native Platform 9 managed Kubernetes cluster, but you can do certain things to bring it under the management of your Platform 9 environment. So that's also something to take a look at when you're trying to get up and running with, especially with multiple different cloud environments and different providers.
Awesome. All right, I'll give another minute. That'll probably end up actually resolving itself. All right, so while that's finishing out, if you want to do this in production, you're going to want to look at, like I said, Jupyter Hub. So this is actually in here. It's linked to in here too. There's actually like an up and running 0 to Jupyter Hub in Kubernetes. It's a project bringing Jupyter Notebooks and stuff to Kubernetes. Like a step 2, like after you do this and you're like, oh, I want to move to the next step, I want to make this available to my users, you would go and look at the Jupyter Hub stuff and get that deployed. That should make life a lot easier than having to manage a bunch of different pods or anything like we're going to do this one off of. So let's see, are we done? Oh, we're done. So now we're going to download our kube config. And I'm going to move it to my other. Give me a second. I'm going to move it to my Linux machine that I've actually got Visual Studio connected to. All right, and then, all right, there, we're good to go. All right, so the cluster's deployed. Next steps, we need to actually add storage. So I'm going to go into the app catalog, and we have the Hostpath CSI driver right here. I'm going to name it. Same thing, I name it here. All right, 1 second. This is making my computer a little bit slow. Demo, we're just going to put it in the default namespace. So app catalog. App catalog lets you deploy basically Helm deployments using a UI, right? Like, so if you've got a repository of Helm charts, then you can import it here, and then that'll let you deploy a bunch of different things that you've configured. We've got some basic ones here. There's a bunch of different community supported ones that you could import to that would add additional applications you could deploy. It just kind of makes it easy to visualize the Helm stuff and give access to your users so they can just deploy from here instead of just using Helm on the command line. All right, so let's go ahead and deploy it. All right. And then if we look at the pods, let's see it starting to deploy in a minute. Take a pod to watch. There we go. And I've got K alias to kubectl, so you're going to see me write K get and that stuff pretty much every time. Okay, so now let's look at what we got here and see if we've. All right, so we deployed a cluster with free tier. We're configuring storage with the CSI Hostpath driver, which we did here. Move on to the next part. So now we're actually going to deploy a notebook. Okay. So like I said, I'm just using one of their basic container images. They have a bunch of different images depending on what you want to do. I'm just using the TensorFlow notebook so that when I upload a notebook into the notebook, when I upload the notebook into Jupyter, the Jupyter UI, what I'll be able to do is not install TensorFlow and everything all over again. So that should kind of speed it up a little bit. But like depending on what you're using, Jupyter actually has a bunch of different options. This one's like about 1 gig. Some of these other ones are a little bit smaller. So you could get like a minimal notebook and then just go through and install everything in each of the different code blocks if you wanted to. So let's go ahead and deploy this. So I'm going to start out. All right, once it responds again, I'm going to start out with a, thanks, Matt. I'm going to start out with a load balancer one, just because I've created the load balancer. And then after the load balancer one's done, I can show you how to do the no port one too. It's basically creating the same thing, except for there's a couple other steps to build the URL that you're going to need. Like I said, I've got Jupyter set up as a entry in my Etsy host file so that it already points to the IP address that I'm going to get. So what I could do is get service, and I can pull the public IP address. You see Jupyter is using the first IP address in the middle LB space. And then let's watch for the Jupyter notebook to go ahead and start running. It's about 1 gig, so it's going to take it a minute or so to download. And then once it's done downloading, all we have to do is look at the logs to find the URL that we actually need to open. I think my video is like pausing a little bit too. I got so much stuff running. Give it about a minute. Some of the other, like I said, some of the other ones are a little bit smaller, so they'll get to a running state a little bit faster. This one probably takes about 2 or 3 minutes, and then it's done. Also, probably slowing down my video downloading this while I'm also deploying it. Some of the when you're streaming, sometimes it's better to have a remote server where you're deploying a bunch of containers and stuff instead of doing it locally on the same network, just because it's going to destroy your connection. Any other words of wisdom, Matt? Or do we have any questions or anything so far?
I'd say remote development is generally favored, so I think you're on the right track there.
Well, so I do have, at least with so I'm running on a Mac, as you can tell, my VS Code, it's not actually running on my Mac. I've got a Linux machine that I'm doing a remote connection to so that I can run everything properly. And I can use Docker, the command line, instead of downloading Docker Desktop now. I think a decent amount of people that are using Macs are kind of using it as like a terminal to some other server now. So you could set up a Linux server somewhere and just connect VS Code into it, which is pretty nice because I get the nice UI of the Mac, but then I also get the ease of use of Linux. I don't know, are you using something similar to that?
I think Golang recently added a similar feature with regards to being able to have a remote executable environment. So definitely looking forward to trying that out. I've been familiar with that with VS Code though.
Actually changed my host name and stuff too because it was something else. So I made it demo. All right, so our notebook is running. Took about almost 3 minutes. So now what we can do is we can look at the logs for that, and we can look at the logs, and what that's going to give us is a URL with a token. You can set the password and stuff. Eventually, you'd want to do that, but for just like accessing it the original time, if you just want to access it and run through these as a demo, you can just copy this. Like I said, I've got Jupyter set as a entry in my host file, so I can just copy paste this instead of having to put the IP address in. But if you don't have a host file set up or anything like that, you're just putting in the IP address, port 888 with the token and everything. I've got that outlined in here too on how to actually get your URLs and endpoints. So if you forget or you want to look at it later on, you can just find it here. All right, so now we've got it running. I've showed the load balancer option. I'll go ahead and walk through the rest of it, and then I can go back and show the noteport option if we have extra time. So what we'll do is we'll go ahead and create a new notebook so that we can just run hello world. It's like, this is just something very basic. Let's see. And then we'll pretend like I'm a noob with Python. And then since this is Python 3, it's a Python 3 notebook. We just hit play, and then there, hello world. So we did hello world. That's the first thing on the agenda. But what we want to do is something a little bit more interesting than that. So I've also included 2 other notebooks that we can download and that we can run through to actually kind of show what kind of resource usage you're going to see on Kubernetes, and how you can kind of see that in the UI, and how you can see it with top. So I've already downloaded this one before. This is an image classification one. So this is one of their tutorials that's going to tell you like which flowers and stuff there are. Now this one is interesting too, because here, I'll download it first and I'll show you the different sections that are really going to push Kubernetes a little bit, depending on what your cluster size is. So to actually upload a notebook, so you would download a notebook here. They have a bunch of different ones that you can download. You would go into the UI and select upload, and we'll do the classification one first. And it's going to take a second or two to upload it. What you don't really see here, but we've configured in with the pod, is it's actually mounted the volume to where, like, if I deleted this and just ran another one, this information is still going to be here. So this is actually all preserved and saved. Say you're doing some testing and you want to like test and save stuff, but you just want to delete the pod or something like that for some reason afterwards, you can do that and then just run it again, connected to the same volume, and you're going to still have access to this. So let me close out this. All right, so for the image classification, basically you can just upload it, and then the parts that are actually really going to push the CPU are going to be, so let me scroll down a little bit. There's a couple of sections that actually have a bunch of different epochs, and you can actually set and change the epochs. It's like epoch 10, like this one is going to take a while. This one was pretty quick on like real hardware, which is what this ran on probably previously. Like, so like if you're running like really good hardware for this, it's going to run through it quickly. But if I'm running on a VM with like limited resources and stuff, this is actually going to take, you know, like a minute or a couple of minutes to get through each one of these. But let's go ahead and go to the top. And what we can do is, once we've downloaded it, we can just click this, which is going to restart the kernel and run all the cells. And then what it's going to do is it's going to step through each of these sections. Jupyter Notebook, if you're used to those, you've probably seen this 100 times. It's going to import a bunch of stuff. And since we already have TensorFlow installed, we don't have to download it again, right? So we're already using TensorFlow image. What it's doing is just going through and it's pulling in the information from that. So from TensorFlow import cares. What we'll do on the other one that we have to modify is actually install TensorFlow Hub. So some of these images, like it has TensorFlow as a base, you can go in and you can modify one of the code blocks and install TensorFlow Hub or anything else you want after the fact to get it running. But this is basically just one of their examples running on Kubernetes now. So I'll keep scrolling down as it catches up. Once we get to the epochs, see, this is where it's actually going to slow down. So depending on what kind of hardware you have, where it's actually training the model, you're going to see like, and we're going to go through 10 epochs and it's going to be like a minute for each one. So it's like 10 minutes just to get this part done. And then there's another section down here that I think does it again for more, just to retrain the model, like 15. That's where you want to actually be looking at having a little bit more hardware than like the virtual machines are running. So like if you really want to test out to see how fast stuff can be, maybe have like 3 bare metal nodes instead of actually running on virtual machines. For me, I only have access right now to the one bare metal node where I'm running VMs just to show off demo stuff. But this is going to run through and finish out. I'll upload the next one, and then what we can do is modify some stuff and run through that one. This one's going to take a little bit longer. So the other notebook that I was going to show off is the object detection. Their example has a section where, first of all, it's going to show the beach scene, and it's going to show you what like each of these objects is or are. And then what you can do is actually modify what you're looking for in here if you want to run through it again, just to kind of see an example of how this works. But it's just training. It's going to train a model, and then it's going to pull the images and stuff that we have within the notebook, and then it's going to filter through each of them and spit out some information about them. I kind of ran through that pretty quick. Do you have any questions or anything like that? I can show node port after this one finishes running. If you want to add a replica of this pod, same URL second. So you're probably going to want to have, like, you're probably not going to share this. I don't know if I want like replicas of it, right? Because it's one-to-one with like the storage. What you're gonna want to use, Kevin, is like something like Jupyter Hub, to where, like, say you've got multiple users, they each get a pod that's running somewhere else. So instead of having like this setup and using the same one for multiple people, it'd be better off if, like, say I'm on node 1 and then Matt's on node 2 or something like that. Especially like with this epoch, let me go ahead and show, that's what I want to show next is like if we look at top and we look at how much resources it's using, like 92% of the CPU is just getting crushed by this right now as it's training the model. So it's better, like, say you've got like a bunch of different worker nodes, to split up everybody between them so that they're not competing for resources. Does that make sense? I mean, you can open up, like, I could run more than one thing at the same time on this notebook. So say, like, if I open up another tab, like, yeah, I could run a second thing on there for myself. But if a second user wants one, it's probably better to have a separate pod for them, because what we're actually doing too is, if you're running this in production, instead of just having, like, right now I'm doing a request of 1 gig memory. So I need to have something, at least a gig of memory to get this running. If you don't give it enough memory to start with, then the kernel is just going to keep dying whenever you hit whenever you start it up, right? So the kernel will die if you don't have enough memory to start. The kernel will die if you have a limit on them. So, like, I could have like requests, and then I could say something like, I want to limit all of these to maybe, 8 gigs or somewhere around there, so that no one's actually using too much of the resources on each of the nodes. I could even limit the CPU too, right, to where it uses a little bit less CPU, so I can get more of these running on each node. But you kind of want to split them up, right? Like, so if I've got 2 worker nodes and I've got 2 people working on it, I don't want both of them going on the same node. I want someone going on the other worker node so that they can utilize a lot of the CPU too. Does that answer your question? Or maybe hopefully that was helpful.
I think just to add on
Yeah.
to that, in terms of resource usage, definitely that's where anti-affinity rules and pod topology constraints can also come into play, in terms of actually enforcing these pods being constrained to different nodes. But yes, also, the recommendation to have separate pods. In addition, it would be good to have them contained within separate namespaces as well, if you were to go that route. But I agree. It sounds like the Jupyter Hub would overall be the better production solution there.
So yeah, say the node goes offline, it's going to reschedule the container. Now, that might kill the kernel on the current notebook that you're running, right? Like, so you run a notebook and it's running through each of the sections. It's probably going to say kernel died because it's not going to have access while it gets rescheduled. But if it's got the same storage, it'll at least load it back up once it's available again, and you'll be able to run through it again. So, like, yeah, the high availability in that's going to be the pod's going to get rescheduled if a node just dies for some reason. Yeah, but like I said, I think, like, what would you see as like an end user is, I think you're just going to see it come up and say kernel died, and then it's going to lose access for a minute. Like, it's going to say can't connect. And then after that, like, it's going to take probably a minute or two for it to spin back up, depending on if it has to download the image again on the other node for this, and then it'll connect to the same storage, and then you'll be pretty good. All right, so let me show our UI too. So our UI will actually give you some of the information about usage too, like which one is let's see if it updates. Is it still running through the epoch? Let's see. You can get some of the same like top stuff in the UI. Which node is it? This one. When I was testing it previously, actually, it was sending me alerts because I only had 8 gigs of memory on it. Where's the best place to go, Matt? Like, because it's not actually giving me real time right this second. Let me see if I can refresh. Like, I should be hitting CPU a little bit heavier on one of these.
I see. Should be updating there in the UI, but if not, it could be pressured right now.
Yeah. Might be a little bit slow right now. The memory is usually a little bit better. I think it's on this node, right? Because the memory is actually getting a little bit used. Let's see. 9%. I guess it does have this top. Okay, that's a good question. Does top show percentage of like a single CPU, or does it show all CPUs? Right. So that's a question for you, Matt. Like if I do K-top nodes, right? Like I've got 8 CPUs. Is that 92% of a single? Like is it single threaded, or is that 92% of available?
I think that should be overall.
Overall, okay.
But yeah, the UI may differ on that as well in terms of what you're saying, in terms of how that gets calculated based on the NUMA calculation.
Gotcha. Well, that makes sense. So it should start using more memory as it like climbs up, and then we should be able to see a little bit more information in the UI. But if you've got a small cluster, you're definitely going to see a lot more of this. Like, okay, 4 gigs. Is that the one that's actually connected? That's a master node. 3 gigs. That's probably this node that it's running on. 4% used. Okay. Let's let this keep running through. See if we have any other questions or anything like that. This is kind of the boring part. This is kind of what you want to get to, though, is you want to get to where you're just actually training models and testing and letting your users like mess around while having access to something a little bit. Like you could run this on your laptop. The benefit is mostly giving someone more resources than they have on their laptop, so that these, training the model is going to be a lot faster, and then inference is going to be a lot faster. But like I said, I'm running VMs a little bit smaller too. So like the examples that you saw before, where it was like 1 to 3 seconds, is probably running on some bigger nodes. I guess I can go ahead and upload the other one and see if I can get it run at the same time. I don't know if that'll actually pressure the cluster a little bit more. I haven't tried running at the same time to see like to kind of show you what it simulating like 2 users on the same pod or running in the same notebook. Like you could theoretically have more than one person working out of this at the same time. Like if you just wanted to have one for testing, but if you want to get production, you're more likely going to have multiple pods. Oh, let me stop it. Hold on. So like with this one, if you're running through this after the fact on GitHub, what I have to do first is, if you notice here, import TensorFlow hub as hub. I don't actually have that installed, so all I got to do is here modify this real quick, and then let's restart it. All right, so then that'll actually install TensorFlow hub, and then it'll actually run through all this. Now this one is another one of their examples. It's just object detection. The neat thing about this one is you can run through it once, and then if you want to change the image type or upload images and then modify it, you can go here. And instead of like beach, I'll select something like birds or phones or something like that. And it's going to basically just load the images, work through it, build a model, and try to figure out like what each thing is. I'm not super advanced at Jupyter Notebooks beyond being able to do some of the demos and mess around and play around with it. I'm more so Kubernetes person, so I'm just trying to show you how to get started with the least amount of resistance to get going, like, and give you some of the examples of things that I've seen where you have to do it or it'll break. Like if you just ran one of the pods and you didn't do a claim for like a gigabyte of memory, running through even these with more hardware, it's just going to fail. I'm sure you've seen it using Jupyter notebooks a lot, where it just says kernel died, and you're trying to troubleshoot it and figure out why did the kernel die, and none of the log information really tells you what's going on. It took me hours of just messing around and reading and troubleshooting to figure out that I have to have a claim of that much. They have some information in their documentation around like running it like locally, like on a Linux server or something like that, saying that you want to specify like around a gig, but I wasn't putting that together with Kubernetes until making some modifications. And then normally like you might set like a limit to be like, I don't want to use too much, especially if like a server is pretty small and only has like 32 gigs of memory. Like I don't want it to use more than 4 gigs. Well, these are going to use more than 4 gigs of memory, and that's another thing that'll just cause the kernel to just die. All right, so this one is this one's still running. This one's running. Let's see what it's doing to our cluster. All right, so we're popping the memory up a little bit more. I'd imagine after the second one is running on there too, we're going to see memory usage up 6, 7, 6, 7 gigs, maybe more. But it's super slow on the VMs, like I said, versus like bare metal. I don't know, do you have any other questions or anything like that? It's kind of just an example of what you're gonna be able to walk through later if you want. Like I've got all of this is documented, even like the install TensorFlow hub and stuff like that. So like if you say after this you want to take some time and deploy it on your own and test it out, go ahead and do that. And then like if you have questions or anything like that too, reach out to me on Slack. Like I've got that information down here too, and I've got my username. So I'm on the community Slack. So like say you do deploy a cluster and you want to test it out, this will let you do it. So this is kind of like an example of like when I was running an 8 gig memory cluster and I was just running one of these, shows like with the UIs. Let me see if I get the UI updated. That's not updating. The nodes are healthy. Everything's looking good. No alarms or anything. I should have just deployed it again with 8 gigs so that I can make it go red instead of just saying, oh, you're doing all right. You're only using like 5 or 6 gigs of 30, so you're fine. All right, so this one, this entire notebook right here is going to take, 10 to 20 minutes to run. So we probably won't end up showing off what happens here. This one's a little bit quicker because I think we're already downloading a model instead of doing a training on it, and we're actually just doing inference with an image set. Yeah.
Okay, you managed to pick quite the resilient infrastructure in order to test this out, but I'm sure if you did this on a single node where you have also the master services running on it, that then you may start to run into a resource crunch. Not that that is something you want to see in production, but certainly if that's something that you want to see how hard to the limits you can push one node, certainly think that that's the way to do it.
So especially if you set the actual available memory pretty low, like if you set it 8 gigs, we're going to give you a warning when you're deploying a cluster saying you want more, like you need more than this. But if you do set it to 8 gigs, it'll still deploy, and you'll start getting alerts once it's at like around 90% usage, because it's trying to share resources with stuff that's running on the cluster too. And it's going to tell you, hey, that's not good. Like when I was doing the demo of this originally, we were sending out alerts saying that, hey, you're using 90%. Like you might want to either increase your memory or figure out what's going on with the workloads that you're running. Honestly, I don't know if we have any more questions or anything like that. I'll let this one run through, and then I'll kind of show what the results were, and then I can run it again. I guess I can show. I guess I could show node port after that's finished if anyone wants to see that. Like say you don't have MetaLB or the IP address space, you just have a bunch of nodes, but you don't know how to set up the networking. I'll walk through it too, like I said, in GitHub on how to build the URL out depending on which one you're using. I guess I can show that here instead of deploying. So if I was deploying with the node port, I'm just deploying it the same way that I did the load balancer one, but instead of receiving a external IP address for the service, when I do get service for Jupyter, instead I'm going to get a port. And then with that port, I'm going to actually have to build it out based on the nodes. So I can do a get nodes and see that, okay, here's an IP address I can use. And then for the node port, instead of having the load balancer IP, you're just going to end up pointing to the node itself with the high level port. So this one's a little bit different of an example than I had. Basically, this would be 30833 from this example, and then you would use the token. So to show that again, what you're doing is you're looking at the logs, which is going to actually have more information now that we've been running stuff. You're going to look at the logs here, and you can copy paste this to get the token, or you can even go to just the without the token information. You could go to the lab itself and use the token to set a password. You're probably used to doing that if you've used Jupyter Notebooks before. But I guess I can kind of show that. That's pretty much the demo. I did want to kind of let this run through, but since I'm running two at the same time, I might not let this one might not finish out that quick since it's competing for resources. I guess I could stop this one in a minute. See, it's still running through like its 10th one, and then it's going to do another 15. So this one's not necessarily going to finish out, but I guess after this 10th one, it can at least visualize some of the results, like seeing if something's a rose or if it's a sunflower or something like that. But for any of these, you could just download one of these and you could test it out. Like say you're just starting working with notebooks and learning TensorFlow. If you got a cluster running and you've got the notebook running based off of the deployment that I posted, you could just download any of these and walk through them and start learning how to use it. If you already know how to use it, then you're just gonna be able to start using resources. But this is also a good location to start looking through tutorials. They've got it on GitHub too, if you want to like look at it on GitHub. And if like something's breaking on it, or if you have questions, you can always go and submit an issue for it too. But that's basically getting started with Jupyter Notebooks on Kubernetes. I don't know if anyone has any questions. Not a ton of questions or anything yet. I don't know. Does this make sense? Is it helpful? Is someone going to deploy something today and try it out? Like I said, you can reach out to me on Slack. Would it be better maybe if we did like a workshop where we walk through it and you deploy at the same time? The difficult part is having access to clusters. You can use or access to hardware. You could use, like Matt said, the OVA. You can use a cloud provider. So within our UI, you can actually add a cloud provider. Oh, there we go. There we go, Matt. Now we're red. now we're crushed. It just took a minute for it to access it. Maybe it's doing like a uptime, or it's looking at like the last like 5 to 10 minutes instead of just being immediate, so that it doesn't just alert you all day. We have plenty of memory too. Yeah, look, we're using 9 gigs, but we are like crushing the CPU. And Kevin, that's kind of one reason why, like I said, you probably want people running on different worker nodes if they can. Also, this is all using CPU, so none of these have GPUs or anything on there. To set up like GPU stuff, it's to be a little bit more difficult, right? Because you have to use the NVIDIA containers with GPU support. I think most people are still doing training and stuff on, if they have access to it, they're using training on the GPU, and then you would use like Kubernetes cluster and CPU for inference. But if you're just testing stuff and you're not moving to production, then you could use CPU for all this. It's just going to be a little bit slower. All right, so now it's just trying to figure out images. Now it's going to go through and it's going to run even more training, and then it'll give us some more information about what it thinks things are. See, this one's actually pretty interesting for object detection. Like it'll show some images and it'll show some boxes around them and show you what it thinks everything is. So you got about like 15 more minutes. This one should finish out before then. Like I said, oh yeah, so cluster. So like you have options to add like cloud accounts like AWS, Azure. So you could run this on hardware there if you just wanted to test it out, run it on some smaller nodes. For me, like I said, I'm just running it on bare metal /VMs. So I'm running on a local server that I have, just in case you don't have any hardware, like, and you want to test this out later. Anything to add, Matt? You're a AI ML guru, right? You've been playing with Jupyter notebooks for a while.
Yeah, that's right. No, unfortunately, I don't have as much experience with it, but along the lines of what you're mentioning, I do think we've done some other blog articles along these same lines as well. I know there was one, for example, to do how to set up with automatic license plate recognition as well, which I personally found to be kind of a neat use case. So, it's definitely something that I think is good to explore.
There's some neat stuff too you can do. Like say you've already trained a model. So in my past life at my last job, what we had is a Twitch stream, and we were watching Fortnite streams to see who had the least amount of people alive. So it was kind of like a red zone type thing. So you could watch the streams that had maybe like 5 or 10 people that were still in the match. And what we would do is we would capture the image of the text at the top right, and we were doing character recognition. So we built a model off of like maybe like 100, 200, 300 pictures, and then we tagged them all and said this is this is what 10 people looks like, this is what 8 people, and that kind of stuff. And then we took that model and we deployed it on Kubernetes, and we had the Twitch API set up to where we could pull stream information, and we were taking screenshots of the top right of the stream every 5 or 10 seconds. And then what we would do is figure out who had the least amount of people alive, and then we would filter it based on that. So you get this like little dashboard where you can like click through like who's got like 2 or 3 people to see like who wins, and then who's got like 4 or 5 people and who wins. So some interesting things you can do with Kubernetes and models. You got Kubeflow and that kind of stuff that you could use, but Kubeflow it's pretty complicated, even on their documentation. So Kubeflow is like a whole platform for it to be able to like serve the models and run Jupyter notebooks and all that, but it's very complicated besides the packaged options. So like doing your own Jupyter notebook to start with is a first step. Learning a little bit more about Kubernetes and how you can make deployments, and maybe you've got the model just sitting in a bucket somewhere instead of having it served locally on the cluster to begin with. Like that'll still work. Eventually, like having everything local to the cluster should make everything faster, because if your model is large or you've got a bunch of like image files that you're trying to train on, then you don't want to be downloading them from like Amazon all the time. But so this is just like showing that the example works on Kubernetes without issues. Like you might have done this on Docker already and seen that it works. Well, Kubernetes, you can give it more resources and it should run a little bit faster than your local machine. This one's just looking at a beach and it's trying to tell you like, oh, this one's a person, 53% kite, 70%. So it just downloaded some images and it did some inference on them based on a model that was already there. I can rerun it again with one of the different ones just to show it. So you could like download this and test it if you wanted to, just to see like what kind of performance you're going to get on your cluster. Or if like you have VMs or something like that and you give it more resources, you can compare like how long it's going to take to run this on something with 8 gigs versus like 16 gigs. Maybe like if you've got hardware you want to test out before you run something on Amazon, or like deploy a cluster there, which you can do with Platform 9. So I'd say like doing this on like the VMs and the actual workshop that I've made is good for testing and learning what you want to do when you're moving to production. This is just more of an intro. When you move to production, at least you'll have some insights into, okay, this thing took 20 minutes when I only gave it like 32 gigs. Maybe my cluster, maybe my worker node size needs to be a little bit bigger. If I've got like five or 10 people working off of it and I've only got like 3 workers, maybe I need to plan for that. If I'm limiting them to 8 gigs per notebook, that means I can run maybe like 3 to 4 people per node, and then figure out how many nodes you're actually going to need if they're all running at the same time. Or if they're distributed and you figure out how many people are running at any given time, that'll kind of help with some of the figuring out like what you actually need for production. So I bet this one's still running. Yep. So now I don't think this one will finish by the time that we're done. Any more insights to add, Matt, before I move over to the thank you? And well, I guess I can let this one finish running too. Or maybe for some of our participants, anything you'd want to see beyond this, like say if we did like a 201, if there was interest in that, would you want to see me walk through deploying a Jupyter Hub and seeing how that works? They have a guide, but it might be complicated if you're not proficient with Kubernetes, or if you haven't really used that much. I could probably create something around this, like a workshop and walk through it. It's gonna be a little bit longer, I think, than an hour. But if not, like check it out. Check out their guide and see how hard it is. And if you want us to do a workshop, maybe reach out to on Slack, say, hey, yeah, that would be really beneficial, and I can start working on something like that too. Does Janae have any comments? Janae put this together for us.
No comments on my end. Just a little tidbit. We'll be sure to send out the recording of this so you all can reference it later on.
Yep. We'll have the recording up. We'll send some information with the follow-up with the recording, and then also GitHub too, in case you didn't copy paste it here and you want to check it out later. All the information, like I said, is in there. And if you join Slack and send me a message, I should be able to respond. I'll try to help you out. Awesome. Thanks for the questions, Kevin. Hopefully this helped you out. Check out the GitHub later. No problem. I guess I can go ahead and wrap it up. Like this next, when it finishes running out, all it's going to do is it's going to like look at birds and try to figure out like what's going on with the birds. Like I didn't write any of this. It's just examples to kind of show that it can run on Kubernetes and that you can see what kind of resource usage you're getting and that you can kind of start planning out stuff for later. If I was running this production, I probably wouldn't be using just like 32 gigs of memory and 8 vCPUs. I'd probably be running something a little bit more hefty. But then if I only have like a couple of users, I'd probably only run like a couple of worker nodes and then just split it among them. All right, let me go ahead and play this one. I'll say thanks for joining us. So if you have any questions on the materials provided, reach out on Slack. And I'm in our public Slack. My username is Petersen. And then there's the link. And then there's the GitHub. There's a GitHub URL again. Follow it, or if there's any updates to it, like if I start adding 201 content, it'll be in there. That's about it. Hey, Matt, thanks. Yeah. Hopefully, hopefully everyone. I saw Matt Smith too. No problem, Matt. I hope it's as easy as it was for me. It took me a little bit of testing to figure it out, but then after that, like each one of the notebooks just ran fine. Like I said, I was pulling my hair out trying to figure out, why does the kernel keep dying? Where are the logs that I can find that'll tell me what is going on with this? But nothing said, hey, you're out of memory. Or hey, there was a memory limit that like broke this. But I think like the common production one is like a gig of requests and then like a limit of like 8. But I mean, if you're running more intensive stuff that you want to add more memory, maybe limit it at like 10 or 12. I haven't seen any of the ones that I'm running hit more than like maybe like 6 or 7 gigs. I think probably closer to 5 or 6. All right. Well, I guess let me check it one more time to see if it finished running with the birds. Yep. There we go. There's some birds. Missed this one, but then we probably just need to train the model a little bit better. But I think I guess that's about it. You got anything you want to say, Matt, to everybody as we finish up?
No, I think you did a great job presenting this and making it look easy, because it certainly does not seem easy trying to get going with this from start to finish otherwise. So I appreciate the amount of effort you put into it. And otherwise, I look forward to engaging with everyone on Slack. We have a whole support team on there, and we're always very active and happy to engage in discussion there. So just let us know.
I'll say if you run into issues, this took me probably like a couple of days of real work to actually make sure everything was working and running, and then modifying the YAML files and updating things, and then figuring out that I had to change the storage permissions with the init container. So if you run into issues and you think, oh man, this was so easy for me, it's not super easy. Like you still have to put a little bit of time in, and it wasn't super easy for me to figure it out. So like if you get frustrated, run into issues, don't get deterred, right? Like you can get it done and figure it out. It's not really that hard, but it's not just, oh, everyone should know how to do this. So if you do have questions, definitely reach out. Like we're here to help. I think that wraps it for today. Feel free to give us some information or respond to any of the emails and let us know if you want to see something like a 201 where we go into like Jupyter Hub, or maybe if you have recommendations for something that you'd like to see around this. I don't know if we'll get too far into writing our own notebooks and going through all of that, but like we can at least show like how it works on Kubernetes. There's other probably resources out there to learn AI, ML, and data science beyond what we're going to be able to provide, just because not an expert on it, more so like how to get it running on Kubernetes. But I think that's it. Everyone have a great rest of your Thursday. I'm going to go ahead and stop the workshop, and thank you.